Hello. Hello everyone. Before starting, please let me know if I am completely audible. My screen is visible to you. Any difficulty you are facing? Am I completely audible? Please let me know. Anyone in the comment section? Please drop a comment, either yes or no. Okay, fine. So I am starting. So we are going to study about the advanced data structures, and this is just an introduction lecture. Advanced data structures. So there are a lot of data structures we are going to study here, but first we are starting with the category of data structure that is called as the range query data structure. So we are studying about the range query data structure. So before studying this range query data structure, we have to understand like at what point our primitive technique fails, so that we need some advanced data structures. So by primitive technique, by primitive techniques, I mean prefix structures. So this is also a technique that we can use to answer the range queries. But at what point these prefix structures fails, so that we need some advanced data structure. So for studying that, first we have to discover these prefix structures, what are the prefix techniques we are going to use, and then where it fails, so that we need to study these data structures, that is the advanced range query data structure. So this is how we are going to study. So first, today's topic is, what we are going to talk about is prefix structures. So this is the first thing we are going to study in this lecture. So now what is the prefix structure? So for that, first let us start with a problem. So we'll be starting with some problem, and we'll discover the topic along with the solving a problem. So suppose you are given an array, any array, you are given an array. Consider any elements in it, say n. So the size of array that is given to you has n elements. So this is your array. Now if you are given some number of queries, say q, and the query is of type like sum L to R. Now what does this query means? You have to calculate the sum from the index L to all the way to the index R. So suppose if you have A0, A1, A2, A3, A4, A5, A6. If you have these as your elements, then you have to calculate, for this query, you have to calculate the sum AL plus AL plus 1 plus AL plus 2 all the way till AR. So this is what this query means. Okay. So now let us first see what is the nice solution. How we can solve it using the brute force approach. So what can be the nice solution? So first we can declare a sum as a solution, and we can traverse all the way from L to R and keep calculating the sum. So suppose if I am using a sum variable, and I'll traverse all the way using a loop from L to R, and I'll calculate the sum. So that will give me the sum of L to R. Now what okay, so what would be the time complexity for this? So suppose if I am talking about the nice solution, this solution, so what would be the time complexity for processing each query? So as in the time complexity, we are always talking about the worst case. So suppose if you are given some query like this, some L to R, in the worst case the L can be 1 and R can be n. That is, it is covering the entire array. So in that case, for processing each query, you would be requiring a order of n time for each query, and now you are given q number of queries. So for that you would be requiring order of qn times. So this would be your time complexity for processing all the q queries. Now suppose if q is comparable to n, like if n is given to you, if the n that is given to you is 10 to the power 5, then the q is also 10 to the power 5. That means this q and n are comparable. So in that case, the time complexity you would be getting is O of n square, and this is inefficient, and we don't want this to happen. This is inefficient, and so like what would be the solution for this? Like what other thing we could do to reduce the time complexity? Okay, so for that, suppose if we are trying to store something. Now suppose if you are given an array and you have an array like this. Suppose this array is 1 based, like indexing is 1 based. So this is your array and the indexes are like this: 1 2 3 4 5 6 and 7, and same goes with the elements. So elements are 1 2 3 4 5 6 and 7. Now suppose if I am creating another array, okay, I am creating another array, and this array is storing the prefix sum. Okay, now what do we mean by prefix sum? What do we mean by this prefix sum? So this means, suppose if pref is the name of the array that we have created, so the pref I would be storing the sum of all the elements till ith index. Okay, so let me represent it diagrammatically. So if this is like first element here would be 0, and the next element would be 0 plus 1, that is 1, then 1 plus 2, that is 3, then 3 plus 3, that is 6, then 6 plus 4, that is 10, then 10 plus 5, that is 15, then 15 plus 6, that is 21, then 21 plus 7, that is 28. So now this is my original array, say A, and this is my newly created array, that is prefix. Okay, so we can call it as prefix array. Okay, now this is like 0th index is this one, so we are not having any element in the 0th index of this array, and we will be having this 0 at the prefix array, 0 at the 0th index of the prefix array. Now suppose if I am talking about two things, one is sum at R and the other one is sum at L minus 1. Okay, we should not use this sum here as we have taken the prefix as our name for the prefix array. So suppose if I am using this prefix R and prefix L minus 1, so in that case what this prefix R would be storing and what this prefix L minus 1 would be storing. So this prefix R would be storing all the elements from A0, not 0 because the array is 1 based index, so A1 plus A2 plus A3, say AL minus 1 plus AL plus al plus 1 all the way till ar. So this is what it is stored in the prefix of r. Now what is stored in the prefix l minus 1? So all the sum from all the way to from a to a1 to al minus 1 would be stored in the prefix l minus 1. Now suppose if I am subtracting prefix l minus 1 from prefix r, now what would happen? So in the prefix l minus 1, I would be having the sum of a1 plus a2 plus a3 all the way till al minus 1. Now this is my prefix r and this is my prefix l minus 1. Okay, now I am subtracting this thing from this one. So this a1 would be neutralizing this a1, this a2 would be neutralizing this a2, this a3 would be neutralizing this a3, and this al minus 1 would be neutralizing this al minus 1. And the thing we are going to get as a result is al plus 1 plus al plus 2 plus all the way till ar. Now can we write this thing as sum of L to R? So yes, we can definitely write this thing as sum of L to R. As so, what we can conclude from this discussion? So we can conclude from this discussion is, suppose if we have created this prefix kind of structure. Okay. So suppose if we have created this prefix kind of structure, then we can answer this sum of LR query as prefix of R minus prefix L minus 1, and this we can guarantee that it would going to get run in order of one time. So here each query we can process in order of one time. So suppose if we are given with the Q queries, then we can definitely process it in the order of Q times. That means if Q is comparable to n, then we can process it in the order of n times. So previously what we are getting, so as you can see here, previously we were getting O of n square time complexity. Okay, so here we are getting the O of n square time complexity, but here as you can see we are getting the O of n time complexity. So this is a much better solution. So this is what primitive technique I am talking about. So this is the prefix structure. Okay, so can we do it only using the prefix sums if we are given only the queries like sum from L to R? Is there any other possibilities, like any other types of problems we can solve with this by using this technique? So yes, definitely we have other problems also which we can solve using this one. Okay, so let us talk about the categories of problems we can solve using this one. Okay, now suppose if you are given any query like f L to R, and if you can separate this thing as f of R and some operator, any operator or any say operation, okay, and f of L minus 1. If you can separate any query like this, you can definitely use the prefix structure on that type of queries. Okay, so for examples, let us take some example. For example, suppose if you are given non-negative and non-zero integers, like only positive integers you are given, and you are asked to find this product of L to R. So definitely you can do this using product of R, you can use the prefix structure in which you would be storing this prefix product. Okay, so you can write it as prefix of R divided by prefix of L minus 1. So this we can definitely use, and here this prefix would be storing the product. Here the prefix would be storing the product of all the integers from index 1 to R, and here it would be storing the product of all the elements from the index 1 to L minus 1. So you can definitely do this, and as we have already put a restriction that all the integers that is given to you are positive, and like if it is positive, definitely it won't be 0, so you will never encounter the floating point exception here. So this is also a category of problem. You can use the prefix structure. Now let us talk about the bitwise operations. In the bitwise operations also you can use it. Like in the XOR, you can straightforward use it. So suppose if you are asked a query of XOR LCR, then you can do it using the prefix structure. Suppose prefix XOR is storing the XOR of the prefix from all the way to index 1 to R, then you can definitely write it as this, and you can process this query in order of one time, each query in order of one time. Okay, now why this happens, we are going to discuss this using a problem. Okay, so we are going to discuss this using a problem, and we have a special cases. We have two special cases. That is and or. So we cannot directly write like and of L to R is equals to prefix of R and prefix of L minus 1. We cannot directly write it, but we can, using some special techniques, we can do this. This thing is wrong. We cannot directly write this. Okay, because yes, you cannot write this, and why we cannot write this, and what different strategy we are going to use here, we are going to discuss this after a while. But and the same technique is going to be used in this and or operation. But before how we are going to talk about how we are going to process the range queries on and or, before discussing that, let us first discuss about the XOR operations, how we are going to use the range queries in XOR operation. So if you have any doubt, please like comment in the comment box so that I will solve all your queries. So this is XOR. So how we are going to do the range queries on the XOR. So before that, suppose, okay, now what is a XOR operation? So suppose if you are given two integers and you are writing their binary forms. So in their binary forms, if the corresponding bits are 1 1 or 0 0 or 0 1 or 1 0, then what is the resultant we are going to get? For 1 1 we are going to get 0, for 0 0 we are going to get 0, for 0 1 we are going to get 1, and for 1 0 we are going to get 1. Okay, so if you notice this thing closely, so what is happening here, you can group them together. Okay, this kind of structure is giving 0 and this kind of structure is giving 1. Okay, so what can we conclude about this? What can we conclude about this? So as you can see, if the corresponding bits are same, we are getting a 0 here, and if the corresponding bits are different, we are getting a 1 here. So suppose if A is equals to B, and if we are taking the XOR like A XOR B, if we are taking the XOR of these two values, we'll be definitely getting 0 as our solution, as our answer. Now suppose if we are having a number x and a number of y, and this x is storing the XOR of say A0, A1, A2 and A3, and the number y is storing a XOR of A0 and A1, and if so say this is our first statement and this is our second statement or say expression. Now if we are taking the x or y, now what will happen? So this x or y, so you are going to take the XOR of this thing A0, XOR A1, XOR A2 and XOR A3, and this thing that is again A0, A1. So now you can see that we have having these two A0s, and these two A0s can cancel out, as the if these two values are the same, then you will always going to get a 0 as your XOR value, and these two are going to cancel the effect of each other. So as a resultant, you are going to get A2 or A3 as your result. So this would be your result. Okay. So now what we can conclude about this? So what is the conclusion? So the conclusion is, we can also write the XOR operation in a similar manner, like XOR of L to R is, if we are storing the prefix structure, then prefix XOR R, prefix XOR L minus 1. So yes, we can write it as this one, and it would work fine, as we have seen the example here. We are taking the prefix XOR of say 3, and here we were taking the prefix XOR till the index 1, and when we took their combined XOR, we are getting the result of XOR of 2 to 3. Okay, so 2 to 3. So you can write it this thing as prefix XOR of 3, XOR prefix of 2 minus 1, that is again 1. So this is what these two things means. So yes, we can definitely use the prefix structure in the XOR operation also. So using this thing, let us solve a problem. Okay, so please let me know in the comment section if you have any doubt in the thing we have studied till now. Any doubts, any sort of doubts? Okay, so the problem is this, you can search in your system also, this Nikit Okay, so we were solving this problem, the Nikita and her queries. Um, okay, so this problem says that Nikita recently read about a XOR operation and she got obsessed with it. She has an array A containing n positive integers. She wants to perform Q queries. Okay, so here she is given with an array containing n positive integers and she wants to perform Q queries on the array. In a query, she gives two integers L and R, like the left limit of the segment and the right limit of the segment. And the indexing is one based, strictly mentioned here in the problem. Now she asks, what is the XOR of all the elements of the array after not including the subarray ranging from L to R, both inclusive? Okay. And Nikita guarantees that in each query, the resulting array is non-empty. Okay. The queries are given in a 2D matrix query having L and R for each entry. Okay, so let us first understand what is the problem statement. Okay, so what is the problem statement here? So problem says that we are given an array and this array only contains the positive integers and we have to do the XOR operation. So before that we are given this n positive integers and the indexing of the positive integers are from 1 to all the way till n. Okay, now we will be given two integers L and R and we have to the result of the query. Okay, so the query is of the type L and R like this, and the result of this query would be the XOR of all the elements except the element which falls in this range. Okay, so except these elements we have to calculate the XOR. So we have to calculate the XOR of this part and this part. So we have to calculate the XOR of A1, XOR A2, and we have to leave these the elements which falls in this segment. We have to leave them, and we have to take the XOR of A R plus 1 all the way till AN. So we have to do this. Now, how we can do this? So can we find the XOR of L to R? Yes, definitely. The strategy we have discussed earlier, the prefix and the prefix structures. So by using that prefix structure, we can definitely find the result of this query from L to R. So suppose if I am storing the range XOR. Okay, suppose if I am declaring a variable called range XOR, which is storing now suppose if I am storing this range XOR in a variable, and this range XOR would be storing the XOR of all the elements from AL to AR, and this we can do using the prefix structure that we have discussed earlier. Now suppose and at the same time suppose we know the XOR of all these elements. Okay, So if the XOR of all these elements is stored in another variable, that is say XOR all, if we have say a variable which is storing this, the XOR of all the elements in the array in XOR all. Now what would happen if we take the XOR of these two variables, like range XOR of XOR all. If we are taking the XOR of this would give and definitely give us the result we want. Okay, so this would be our final result. So our first target is to calculate this range OR, and suppose if we are having this prefix OR which is storing say the prefix structure for this XOR values. So now what we are going to do is we are given an array, and on this array we are going to create a prefix array. So this is our array, and this is our prefix XOR array. Now suppose if these are the elements A0, A1, A2, A3, A4, A5, A6, I'm going to create a prefix OR on this array. So the first element would be storing 0 as a result, the second would be storing A0, the third element would be storing the XOR of A0 and A1, and here this third element would be storing the XOR of A0, A1 and A2, and in a similar manner the last element would have the XOR of all elements. So you can get the XOR of all elements just by referring to the nth value of this prefix of array. So this prefix or the nth element of this prefix or array would be storing the XOR of all the elements. So we have calculated this XOR of all the elements we have calculated. Now what the next thing we need? So we have calculated this thing. XOR all. Now we have to calculate the range XOR. So for range XOR, what we can do is we can take so for range XOR, so we can calculate the range XOR by accessing this prefix XOR value of the rth index and taking the its XOR with prefix XOR value of minus 1th index. So this would give us the range XOR, and then we will take the XOR of both of this both of these values and we'll get a result. So this is the idea for the solution of the problem. Let us code it. So I hope you understood the idea for the solution. So here we are given this n. This n is the size of the array. The q is the number of queries we have to process. This a is the array, the given array, and this is a 2D vector, like an array of vector which is storing the queries. And here you can see the queries in the form of like 3 to 8, means we have to process the query for left limit 3 and the right limit 8. So this is how we are going to do this. So the first thing we have to do is we have to declare a prefix XOR array. And the first value of this would be 0. And now we have to traverse all the way from I equals to 1 to I less than equals to n, and here the n is capital 1, and we have calculated this prefix or value, and this would be prefix or of I is equals to prefix or I minus 1, the previous value that is stored in it, XOR A, and as you can see, we are given an array, so the index of the array would be starting from 0 itself, but in the question the index is given as 1 based indexing. So for that, the query that is that we are accessing would be 1 based, but the array originally here is 0 based. So for that, instead of writing I, to access the current element, we have to write I minus 1, because the array itself is 0 based. So this would store the prefix OR. So we have created our prefix structure. Now we have to return a vector as a result. So each element in the vector would be storing the result of each query. So for that, we have to first declare a result vector, and along with this we have to traverse for all the query, and suppose if I am taking the left as the left limit of the query, and I am storing the right limit of the query in the right. So left and right is storing the boundaries of the query. Now the first thing we have to calculate is range XOR. So that is nothing but the prefix XOR of right XOR prefix XOR left minus 1. And now the solution would be XOR of this range value and the XOR of all the n elements. So the XOR of all the n elements would be stored in prefix XOR of n. So this is storing the XOR of all the elements. Now we have to store it in a vector that we have declared already, that is the result vector. So we have to write this. Now the result is storing my result vector, and at last we have to return this result vector. Okay, so everything looks fine to me. Let me check once. Okay, so let us check it. Okay, so it is the correct solution. So this is the idea behind using the prefix structures. Okay, so we have time, we can cover one more part. So whatever we have studied right now is about the prefix queries, not prefix but the range queries. And in this case we are given a problem in the form of query, and we have to give the output for that. Now we have another type of use case, that is range updates. That is range updates. Okay, so now what do we mean by range updates? So for that, understand the use case. So like, let us discuss about this use case. We are given an array, and in this array we have some elements, and the size of the array is n. Now suppose you are given this q queries. Now these queries are the problems, these are the updates, and this update would be in the form of update LR, and this means update L to R with a value of x. So this means that you have to update the array from L to R, and you have to add this x value in all the elements in the which falls in this range from L to R. And you have q number of queries, and at last, after processing all these q queries, you have to return the modified array. This is a modified array, and you have to return this modified array. Now what would be the naive way to do this? Naive way. So what is the naive way to do this? So we can traverse from all the way from L to R, and we can individually update each element. So for that, if you calculate the time complexity for this one, so the worst case time complexity for processing each query here would be O of n, and as you have to process q queries, this comes out to be order of q into n, and if q is comparable to this, it would be O of n square. Now can we do it in some better way? So yes, definitely. And suppose we already know this prefix structures, how we use the prefix structures. So using this, we can achieve a better time complexity than this one. So if you notice the range updates, in the range updates, all the elements in the range is going to behave in a similar manner. Like suppose if you are having a query update L to R, if you are having a query like this, then all the elements AL is going to get updated by X, AL plus 1 is going to get updated by X, and all the elements in this range like AR is going to get updated by X. So all the elements is going to behave in a similar manner. The first change is going to occur at the boundaries. Like here the elements is going to remain the L minus 1. Nothing is going to get added in this element, and the nothing is going to added beyond that element. So the only thing that is important to us here is the boundary elements, that is the Lth element and the Rth element. So we have to do something on this Lth element and the Rth element, and we would be done, and we can using that update we can check the results. Okay, so I think my screen is freezing. Let me check. Okay, so now suppose if we are given a query like this, update from L to R, and we are talking about this thing that only the boundary elements matters. So now suppose initially we are having some elements in the array and all the elements here is 0 now, and suppose these are 0 based indexing, so this would be the index. And suppose if I am giving you a query update 3 to 5 by a value of x. Okay, now suppose if I am writing if I am creating another array, if I am creating another array, so this is the other array, and all the elements in this array is 0. And now suppose if I am adding plus x at this index, that is the third index, and if I am adding minus x at 5 plus 1th, that is the sixth index, and then if I am taking the prefix sum of this array, now then what would be the effect on this array, newly created array? So this value is going to be the same 0, this is going to be the same 0, this is going to be the same 0, and here it would be 0 plus x, that is x, now x plus 0, that is x, now x plus 0, that is x. Okay, so someone has mentioned the strategy and definitely he is correct. She, I think. So this is what is going to happen in the newly created array. So if you notice the effect here, the value at the third index is updated by the value x, the value at the fourth index gets updated by the value x, and the value at the fifth index gets updated by a value of x. Now, and all the other values still remains the same. So what we can say, if we are given q queries, if we are given q queries, if we are given these q queries, we can add the plus x. Suppose the queries are like lr x, l1 r1 y. So in that case, what we can do, at the lth we can add that value, and at the r plus 1th index we can subtract that value. This is lth index and at the r plus 1th index. For each query we are going to do the same. Whatever value we are given with, we are going to add at the lth index, and then we are going to subtract whatever value we are given with at the r plus 1th index. Why r plus 1th index, why not rth index? Because if we subtract that value in the rth index, then the effect of that value at that index would also be lost, and we want that its effect should remain till that index, and after that it should be lost, as you can see in this array. So for that we have to subtract that value at the r plus 1th index instead of subtracting it at the rth index, and after that we can take the prefix. After that we can take the prefix sum, and then this newly created array would be storing the value that we need to add in the original array to get the complete solution. After taking the prefix sum of this array, we are going to add these values we are going to add these values in this array, and that would be our final solution. That's the final solution. As in this array all the elements are 0, you cannot notice the change here. But if the elements are given, if the elements are randomly given to you, then here then you can notice the change. And here I have created this new array to first understand the concept, but we can definitely do this in the single array also. We can do this in the same given array. How? So suppose if we are given some elements, and if we are taking the difference of the consecutive elements, and if we are storing that in our array, and after that if we are taking the prefix sum, this would give us the same array. So we will be taking the difference of the consecutive numbers, and we would be updating the queries on that difference, and then we would be taking the prefix sum. So that would give us the same result. So in that case we don't need this extra array here. Okay, now so what I am saying is, suppose if I am given an array and the elements in the array are like this: A0, A1, A2, A3, A4, A5, and A6. And now suppose if I am storing the consecutive difference here, so this would be A0, this would be A1 minus A0, and this would be A2 minus A1 plus A0, something like this. Now if you add these values, you will be getting, so in this manner you can create the complete difference array. So this is called as the difference array. This is the difference array, and this is another technique we are going to talk about. Okay, now this is our difference array, and suppose if you are taking the prefix sum of this one, so the first value would be A0, and the next value would be A0 plus A1 minus A0, and this A0 would neutralize each other's effect. So that would be A1, and after that here we have only A2 minus A1, as we are taking only the consecutive difference, and here we will be having A3 minus A2, and here we will be having the A4 minus A3. Now this A1, if we are adding this A1 to the third element, that is A2 minus A1, we will be getting A2, and if we are adding this A2 to this value, that is A3 minus A2, we are going to get A3. So now suppose if we are taking the difference array, and at last, so here we have created this difference array, and in the last if we are going to take the prefix sum of the difference array, we are going to get the same array. So why we need to say use the another array for doing the updates, why we need another array? We can just convert this array into the difference array. Okay, so for that we have to create it from right to left, otherwise the value would be lost, because suppose if you have updated the A1, you won't know the value of A1 while calculating the A2. So you can do this from this right to left, and you can calculate this difference array. Now your difference array would be your new array, and then you can use the same strategy of doing the updates, like adding the except value at the L plus 1 at Lth term, and subtracting it at the R plus 1 term, and you can do the updates here, whatever the updates is, and in the last you can just take the prefix sum, and you would be getting your final modified array. Okay, that is your final solution. So you can do this in the same array that is given to you. So for that, the time complexity would be O of n, because O of 1 would be the time complexity for processing each update, and as you are given q updates, or say q is comparable to n, so in that case O of n into 1 would be the time complexity for processing each of the updates. So the time complexity would be order of n, and the space, and here the extra space you are using is O of 1, you are not using any extra space. You are just doing the modification in the same array. So this strategy is called as the difference array. Okay, now let us use this strategy of the updates to solve one more problem, and then we will be finishing off this session. So the problem says that the problem is max value after m range operation. So the problem is given an array of size n with all initial values as 0. So we are given an array with all the values as 0, and the task is to perform the m range increment operations. Okay, so these are equivalent to updates, and the increment operation is like ai to bi, and this ki value by this ki value. So we have to increment the values from index ai to bi by this ki amount. Okay, this simply means that we have to move all the way from ai to bi, and we have to increase all the elements by this ki value, and we are given this m operations, and at last we would be getting a modified array in the last, and there we have to calculate the maximum element in that modified array. Okay, so the problem statement is very simple. You are given an array, and all the elements in that array is 0. You are given an m operations in the form of ai, in the form of b. So we have to increment all the values from ai to bi by a amount of ki. So all the operations are only of this kind, and after doing this we would be getting a modified array, and in this array we have to run the maximum elements. Okay, the idea is same. We are going to increment the ki at the ai index, and we are going to subtract this value at the bi plus 1th index, and then we will be taking the prefix sum, and then we will be calculating the max value among them. So this is the idea. This is a very simple problem, and one thing to note here is we have to create the array having an extra size, like one more block, because always we are accessing the bi plus 1th index, and suppose if the query that is given to you has n as your bi, that is the complete size, then in that case you would be accessing the n plus 1th index, and in that case it would be giving you garbage value. At other times it would be simply a runtime. So to get rid of that, we would be declaring a array with one more block as its size. So let us write our code. So here this n is the size of the array, the m is the number of queries, a is the given array, a, b and k is the kind of queries. Okay, ai is the left limit of the query, b is the right limit of the query, and the k is the update we have to make. Okay, so first we have to declare an array of size. So this is our array, and the size of this should be one more than the given size, and all the elements here is 0, and let us make a variable to keep comparing the maximum value, and then we will be traversing all the way from 0th query to mth query, and we'll be doing these queries. We are updating these queries. So for that, first thing we would be doing is at the aith index of the array, we are going to add this kith value and at the bith plus bi plus 1th element of this array, we are going to subtract this kith element. So this would update the entire result. Now after that, to get the modified array, we have to take the prefix sum. So what we can do is, instead of declaring it here, we can declare it here, and we would be initializing it with some value that we would discuss later. Okay, but before that, we are going to start from the index 1 all the way till n minus 1th index, and what we are going to do is, we are going to take the prefix sum. So that is nothing but the arr I. We are going to add the previous value in this one. Okay, and then this arr I is storing the modified array. So we have to compare this with the maximum value. Okay, so we'll be comparing this with the maximum value, and then we have to return this max value. Now as you can see here, we are starting from the index 1, because if we start from the index 0, every time we are accessing this I minus 1th index. So 0 minus 1, that is the minus 1 index, that doesn't exist, and so to get rid of this, we have started it from the 1th index. But here it hasn't checked the arr 0 yet. So what we can do, we can initialize our max value with that value, so that it would also get checked. Okay, now let me check once. We have created an array with one more size than the given, and then we did all this, and yes, this code seems good to me. Let us check it. Okay, so yes, this is the correct solution. Now what we have discussed in today's lecture. So conclusion, what we have discussed in today's lecture. First, we have discussed this primitive strategies, in which first we have talked about the prefix structure, and then about the difference arrays. This is used for the range queries, and this is for the range updates, and they give the best time complexity. But now suppose we have some advanced problem statements in which these range queries or range updates or say point updates are intermixed with each other. So initially these queries are offline. Like if you have to do some updates, first you have to do all the updates, and then you have to calculate the result. Or so if you have something like dynamic queries or like online updates, like you are doing the queries as well as you are doing some point updates or say range updates, and then again you are printing some queries. So in that case you cannot use these structures, because suppose you have updated few times, like 1, 2 or 3 times you have updated, and then you got a range query. In that case, first you have to take the prefix sum of this one, and then you have to process this range query, because then only you will get the correct result. So for each operation you get the O of n each query you are going to take the order of n time, and for n queries you are again going to take the order of n square time. So this is not the perfect solution for the dynamic queries or say online updates. So in that case, the range query data structure is used, that we are going to see in the next lectures. So this is all for today.